Hi, Nick Collier here, and this is my shop. Come join me. We'll have some fun. Well, here we are again, Nick Collier, and we've got another project. This one is kind of a complicated process. I sent out a request here a week or so ago, got a great response, told me do not buy one of the mini lathes, which I decided not to, and the majority of you said they're pieces of junk, forget about it. So I didn't even go any further than that, and I appreciate the input there. But I kept looking at this jet lathe, the jet series. And, I kept thinking, well, it's probably a pretty cheap lathe, but I don't need a bunch of bells and whistles. All I need to do is this one project, and I'm going to be doing it over and over and over again over the next however many years. And so I bought a jet lathe, and it's it's a basic lathe. It's a little dinky guy, but it's got the potential that it needs. When I bought it used, by the way, on Craigslist. So I went over to this place and I tested it to see how much run out is on the bed, and it's just, within a couple of tenths, which is fine by me, and that's at about 6 or 8 inches, which is all I really need. And so I bought it. Well, actually, the company that's going to hire me to make these parts, and I'm going to show you the part. And this was a long process to get to this version using my my big Moss lathe, which is completely worn out, and it was a scene getting there. But hopefully we're going to get this thing set up so that this is all this does is cuts this, and I don't know if you're going to be able to see it or not. Oh yeah, you can see it. So you can see this is just one design. There's like probably, she said there would be literally 3 or 4 designs a week. And we're going to get paid well to do it if we can do it. So it's a matter of making this lathe work in the way that we want it to work. So I start with a piece of 1/8 inch rod, at least for this part of the project. She said that the rod gets no bigger than 1/4 inch and no longer than 8 inches. So all of this fits within that realm. Let's see, where else were we gonna go there? The problem. The problem is I got it home and I was hoping just to set up the gearing so that the carriage drive traveled really slow. And I could not get the carriage drive to travel any slower than 100 RPM, which is, this thing's moving along fairly fast, and we're getting a fairly rough cut. And what I needed was to be able to come up with a smooth cut, and I'm going to see if you can see that. But right there, last night I did a quick test and was able to come up with a fairly smooth cut. A little bit of sandpaper work, and I think we got it. But what I ended up having to do is disengage the gearing completely and come in with a little small motor that I got off eBay. It wasn't cheap, but it does the trick. And so we're going to come into the end of the drive rod and put the motor connect the motor up to the drive wad. Now I tested this and it works beautifully, and this is a 15 RPM motor. Well, you know, drive reduction motor, and it's strong enough to carry this and to drive it, no sweat. So what we've come up with is a way, we need to come up with a way that this motor is going to sit right here. And what the problem is that the motor travels too slow for the rough cuts. And so I've got a second motor on order, and we're going to come in and build a bracket for the motor so that I can disconnect the motor fairly easily and put another motor on there to travel about 60 RPM, which is gonna give me a little coarser cut for the hog cuts. You know, hog cuts. What I'm gonna run about 8 cuts at about 5 thousandths, maybe. That's 5 thousandths, the 2.5 thousandths per cut. So we've got the thing cleaned up. We've got it all set. I sharpened a bit and tested it out, and you can see it's got a pretty good rake on it. And the only thing I need to continue to do is keep playing with this radius out front here until I can kind of gap over the speed of the carriage. So last night I got in there and just put probably about a 20 thousandths radius on there, and we'll test that out at some point soon. She's given me a month, or I've asked for a month, to tool up this lathe and get it running properly and get everything all set. Now we've got a collet head showing up at some point or another, and so one of the problems was, you know, this thing's hanging out while I'm trying to cut it, and you know, at some point she says that the smallest diameter is 20 thousandths, about 20 thousandths. But, you know, if you just take it easy and go slow, and, you know, as I said, I'm getting paid pretty good for this, so it's worth the effort. So anyhow, so what I needed was some support out here, or else this whole thing's just going to flop around. So what I've come up with, and I wanted to video it, I just got so excited about doing it that I forgot. And if you'll notice, what I've done is built a little chuck that will, turn. I took a live center and I turned it down to fit this drill head, and now if you'll notice, the drill head floats with the chuck. And as I said, eventually we're going to have a collet system in here, so that'll be better. And and at the same time, drilled the hole all the way through this, all the way through this, all the way through that. So if you'll notice, we can, when we index, I can slide this sucker all the way in. So we can start there, up close, and then work our way back. Well, no, we start here in the collet with the original size and do like an inch or an inch and a half of material, and then open the collet and slide it forward and do another inch and a half, and then slide it forward and do another inch and a half until we get our piece done. So that kind of gives you a overview of where and our plan is that the carriage screw has got a threaded cap on it, or end on it, and I made up a really quick adapter to go to this, and you can kind of see that it goes right on there. Well, it's supposed to go on. There we go. And that adapted to this motor that I tried out, but it just didn't travel slow enough. So now what we have is this motor goes into that adapter and then gets bracketed to this piece of steel, which sits right there. So drill a hole, drill 4 small holes for the motor bracket. But what I want to be able to do is I want to be able to remove this thing and put it back and put the faster, I've got a faster one coming. I want to be able to remove this thing and put it back without too much effort. So I think what I want to do is I'm going to bolt this to the end of the lathe, and then take another piece of steel and bolt the piece of steel to this, maybe with one bolt and a indexing pin, or a couple of indexing pins. So that's where we're at, and that's going to be able to, and I disconnected the entire drive system. There's the issue, there's the problem. We're going to come in and drill holes in this plate and drill holes in the end of this, maybe 3 holes, and get this thing to sit here, and then adapt the motor to it. Oh, and also we have to build a new adapter. What I want to do is have maybe a hex head adapter go to it, so that the motor can just come off and go back on without taking any screws out or anything like that. So let's get started. All right, we're set up in the mill. I'm thinking we're not needing anything more than about a 1/4 inch hole for a 1/4 inch bolt. Anything more than that, it's kind of overkill. I mean, we're not talking, the motor's not pushing and pulling on this, it's rotating. So there's really no need for overkill in this situation. If I remember correctly, this thing is going pretty slow. Alright, that's pretty good. Now what I need to do is figure out where my 3rd hole is going to be. So I'll be back. Okay, so we want to get this thing into position so we can drill the holes into the lathe itself. And I think we use a wood clamp. And all we want to do is get ourselves a mark in here. Looks good. Oh, except we don't want to use a 1/4 inch bit. We want to use a number 7 because we want to tap this. Alright, so now we just put some pressure on it. I like it. Alright, let's tap these 2 holes, see what we can come up with. Okay, well, these are not the correct Allens, but for the moment they'll do the trick and they'll get us locked in so we can go from there. Okay, well, now we have to figure out where this shaft lands on the plate itself. And the only way I can figure to accomplish this is to take a piece of tape and put a pin, and all we're getting is a general hole because we're going to oversize it anyhow. Okay, so I've hooked up my gears again, and now we're going to just turn it on and let it spin. Oh, look at that. Man, is that slick or what? Okay, so let's take it off. And we know that our hole is right there. Take off our plate. All right, let's get it set up on the hole there. And we're going extra big, so it's not real critical exactly where the hole is, but you know, I like to be as close as possible. Something about right there, I'd say. All right, let's give it a shot. That looks pretty good. All right, take our piece. Oops, that's going way too fast. Looks good. Looks good. All right, we'll take it back over there and see what we can do. All right, let's see how our little motor is going to mount up here. Looks like it's going to fit just about right. I like it. So I think what we need to do next is we need to come up with some, well, oh yeah, we need to come up with our back plate. that's going to give us the ability to take this off and put another one on. Okay, I've got my little motor in place here, and I've decided just to go directly to this plate and put 2 screws in and 2 pins in, so that, you know, it's easy to take out and at the same time, it, you know, not a big hassle. So what we have to do first before we do anything is we have to connect the motor shaft to the drive, what would it be called? Screw. Okay, so we're going to take 1.5 inches, and that might not be long enough. Yeah, it's long enough. And I couldn't find any 3/4, so we're going to take this piece of 1 inch and take it down to 3/4, which is not too big a deal. Let's kick in. I just remembered I got to put a set screw in here, and we want enough meat to do that. So we'll stop there. Let's get ourselves a center drill going. All right, back that up, figure out what M8 125 is. That should get us fairly close to what we want. And we're going to take that all the way through just to make sure that the hole is concentric with the outside, and then we'll come back in later and drill this out to, yeah, 312. So no problem. Okay, we're there, we're tight. We're going to go in 1.5 inches. All right, we took it 1/8 over 1.5 inches, so it's back there a ways, just to make sure. Now we'll take our M8 tap. Got one of these little tap guys that I made up. I saw this on the internet. You know, you basically slide. Whoops, that's not the right size. Basically slide this in, and it locks in the top, so you're not putting it in the chuck and wearing down your numbers on the shaft. So I like that design. So if anything slips, it's the little sleeve. So we've got ourselves loose. We're going to spin this up. We're going to run it in. Actually, we could run it in further. And then it just pops out. Okay, so now how far in are we? And we need to go further. Let's get a little juice on it. Back out. Now we have to, well, plus we have to deburr that, but we also need to bring that little shoulder in right here down to that size. So yeah, I think we got her. Okay, let's spin this around. Well, first we're going to take it over and cut that off and then spin it around.